Hi everyone, this is Ramkrishna. Welcome to my channel. In this video, we will discuss APSET 2020 Complex Analysis Paper 2 Complete Solutions. So, in this year 2020, we got total 6 questions from complex analysis, and these 6 questions are very standard questions. So, let us see the questions. So, first here we have question number 21, and the question is for any complex number z, cos z is equals to. So here we have 4 options. Option number A, summation n is equal to 1 to infinity minus 1 whole power n into z to the power 2n plus 1 by 2n plus 1 whole factorial. Option number B, summation n is equal to 0 to infinity minus 1 whole power n into z to the power 2n plus 1 by 2n plus 1 whole factorial. Option number 3, summation n is equal to 1 to infinity minus 1 whole power n into z to the power 2n by 2n factorial. And option number D, summation n equal to 0 to infinity minus 1 whole power n into z to the power 2n by 2n factorial. So we have to choose one correct option from these 4. Okay, so here the question is about to find the expansion of cos z. So we define the function cos z by power series as, so coming to the solution, we define the function cos z by power series as cos z is equals to 1 minus z square by 2 factorial plus z to the power 4 by 4 factorial minus and so on plus minus 1 whole power n into z to the power 2n by 2n factorial plus and so on. That means here in cos z expansion we have all powers are even powers. So this summation can be written in the form summation n is equals to 0 to infinity minus 1 whole power n into z to the power 2n by 2n factorial. Okay, so cos z can be written as summation n is equal to 0 to infinity minus 1 whole power n into z to the power 2n by 2n factorial. If we put n is equal to 0, so we will get the first term, that is minus 1 whole power 0 means 1, z to the power 0 means 1, so we will get the first term as 1. So this is the cos z expansion. So that means our option number, is it clear? So this is question number 21. Now moving to the next question, that is question number 22. So that is if f is a mapping from C to C, means complex plane to complex plane C, is defined by f of z is equal to e power I theta into z, then f is called a dash, and we have 4 options. Option number A, rotation. Option number B, translation. Option number C, dilation. And option number 4D, inversion. So this is related about Mobius transformation. And the solution is, if S is a Mobius transformation, and if we define first one, S of z is equal to say z plus a, then it is called translation. Okay, if the given Mobius transformation is of the form, say S of z is equal to z plus a, then it is called a translation. If S of z is of the form az with a not equals to 0, then it is called a dilation. Okay. 3, if S of z is equal to e power I theta into z, then it is called a rotation. Okay, it is called a rotation. And another one, if S of z is defined to be 1 by z, then it is called an inversion. So these are some definitions in Mobius transformation. So here the question is, if f is a mapping from C to C is defined as f of z is equal to e power I theta into z, then f is called what? Here s of z is equal to e power I theta into z, then it is called a rotation. So our option number A is correct. Is it clear? Therefore option A is correct. These are all basic things in complex analysis. Okay, is it clear? Next we have question number 23, and the question is, let f is a mapping from C to C, means complex plane to complex plane C, be a non-constant analytic function, and x is equal to set consisting of all complex numbers z belongs to C such that modulus of z is less than 2, then f of x is dash. And the four options are option number A, closed in C, option number B, open in C, option number C, compact in C, and option number D, bounded in C. So here we have to choose one correct options from these four. And here the question is about to find the image of the set X. Here the given set X is equal to set of all z belongs to C such that modulus of z is less than 2. Then we have to find f of x is dash, and here given that f is a non-constant analytic function. Here f is a non-constant function and it is an analytic function. What do you mean by analytic function? We know that analytic function means it is continuously differentiable function, means derivative of f exists and it is continuous on every point of C. Okay, here given that since x is equal to set of all z belongs to C such that modulus of z is less than 2. Clearly this is an open set because modulus of z is strictly less than 2. So that means if we take center 0 and radius 2, so this represents modulus of z. So it is an open ball with center 0 and radius 2. So clearly this is an open set. So x is equal to set of all z belongs to C such that modulus of z is less than 2. And given that f is a mapping from C to C, that is an non-constant analytic function, and f is a mapping from C to C is a non-constant analytic function. Okay, so that means f is continuously differentiable on complex plane C. We know that a continuous image of an open set is open, and clearly here given that X is an open set, so clearly this is an open set. Okay, we know that continuous image of an open set is open. Hence we have the image of X means f of capital X is open set in complex plane C because f is a mapping from C to C, and here X is equal to set of all complex numbers z belongs to C such that modulus of z is less than 2. So here this is a set which represents a open set with center 0 and radius 2. So clearly this is an open bar. So continuous image of a open set is open, so clearly f of x is open in C. Therefore option number B is correct. Is it clear? Option number B is correct because here option number B is open in C. Okay, Now moving to next question, that is question number 24. So here we have the question is let sequence an be a sequence of real numbers such that limit modulus of an by an plus 1 here as n tending to infinity. So limit n tends to infinity modulus of an by an plus 1 exists and equals to alpha. That means this limit of the sequence exists and it is equals to alpha, and r be the radius of convergence of this power series n equal to 0 to infinity an into z minus a whole power n. Then we have four options. Option number A, r equal to alpha. Option number B, r is less than alpha. Option number C, r is greater than alpha. And option number D, r is not comparable with alpha. So we have to choose one correct option from these four. And here this is standard theorem in complex analysis. First we have to recall that theorem. So here we are writing the theorem statement. So theorem is if summation n equals to 0 to infinity an into z minus a whole power n is a given power series, with radius of convergence capital R, then R equals to limit n tends to infinity modulus of an by an plus 1 if this limit exists. Okay, this is a standard theorem in complex analysis. So here the given question is an be sequence of real numbers such that limit n tends to infinity modulus of an by an plus 1 exists and it is equals to alpha, and r is the radius of convergence of the power series. Now comparing the theorem, here r is the radius of convergence of the given power series and limit of the sequence is alpha, that is the given hypothesis. So here r must be equal to alpha. So therefore option A is correct. Is it clear? Therefore option number A is correct option. Okay, we will see the next question. Next we have question number 25, and the question is let capital G is equal to set of all z belongs to C such that modulus of z is less than 1, and f is a mapping from G to C be defined by f of z is equal to cos of 1 plus z by 1 minus z. Then the set of zeros of f is dash, and the four options are option number A, set of all n pi minus 2 by n pi plus 2 such that n is an odd integer. Option number B, set of all n pi plus 2 by n pi minus 2 such that n is an odd integer. Option number 3, set of all n pi minus 2 by n pi plus 2 such that n is an even integer. And option number D, set of all n pi plus 2 by n pi minus 2 such that n is an even integer. We have to find the correct option from this four. And here the given question is G is equal to set of all complex numbers C such that modulus of z is less than 1, means this is an open set. So here it represents a open sphere with center 0 and radius 1, because clearly this is an open set because modulus of z is strictly less than 1. And f is a mapping from G to C is defined by f of z is equal to cos of 1 plus z by 1 minus z. So we have to find the zeros of this function f of z, and we know that the zeros of cos z is given by, if we equate cos z is equal to 0, then z value is equal to 2n pi plus r minus pi by 2. So the zeros of cos z is given by cos z is equal to 0. That implies z is equal to 2n pi plus r minus pi by 2, where n is an integer. So from this we get z is equal to 4n pi plus or minus pi whole by 2. So this can be written as 4n plus or minus 1 into pi by 2. Here n is an integer. So this is the zeros of cos z. But here the question is about to find the zeros of cos of 1 plus z by 1 minus z. Okay, so here we have to equate cos of therefore the zeros of cos of 1 plus z by 1 minus z is given by equating cos of 1 plus z by 1 minus z is equal to 0. From this we get 1 plus z by 1 minus z is equal to, that is 4n plus or minus 1 into pi by 2. Is it clear? Now we will simplify this. Here n is an integer. Okay, so on simplification we get this can be written as cross multiplication. We get this is 2 plus 2z is equal to 4n plus or minus 1 into pi minus z into this term, that is 4n plus or minus 1 into pi z. Taking z terms as one side, we get this is 2z plus 4n plus or minus 1 into pi z is equal to 4n plus or minus 1 into pi minus 2. Okay, taking z terms as one side. So here from this we are taking z as common. This can be written as taking z as common, we have this is 4n plus or minus 1 into pi plus 2. This is equal to 4n plus or minus 1 into pi minus 2. Okay, so from this we get z is equal to 4n plus or minus 1 into pi minus 2 whole by 4n plus or minus 1 into pi plus 2. So this can be written as, if we treat 4n plus or minus 1, this is clearly an odd integer because 4n plus 1 is an odd integer. If we take this is an n, so we have the set of zeros are given by set of all n pi minus 2 by n pi plus 2 such that n is an odd integer. If we take 4n plus or minus 1 as n, some odd integer. So the set of zeros of cos of 1 plus z by 1 minus z is given by set of all n pi minus 2 by n pi plus 2 such that n is an odd integer. Therefore our option number A is correct. Is it clear? So our option number A is correct. Last we have question number 26, and here the question is, let f and g be analytic functions defined on a region capital G such that set of all z belongs to G such that f of z is equal to g of z has a limit point in G, then which of the following is true? And four options are: option number A, f of z is not equal to g of z for some z belongs to G; option number B, G is compact in C; and option number C, G is bounded in C; and option number D, f of z is equal to g of z for all z belongs to G. And this is a standard theorem that is known as identity theorem. So first we have to recall the theorem, and before going to discuss the theorem, first see the statement of the problem. Let f and g be analytic functions defined on a region capital G such that set of all z belongs to G such that f of z is equal to g of z has a limit point in G. So the set consisting has a limit point in the given region capital G. Then we have to choose one correct options from this four. So now we have to recall the identity theorem. Identity theorem. So here we have theorem statement is, if f and g if we have f and g are analytic on a region capital G, then f is identically equal to g if and only if set of all z belongs to G such that f of z is equal to g of z has a limit point in capital G. So by using this identity theorem, we have option number D, that is f of z is equal to g of z for all z belongs to G. This is the correct statement, because given that the set of all z belongs to G such that f of z is equal to g of z has a limit point in capital G, and this statement satisfies all the conditions of identity theorem. Therefore, our option number D is correct. Is it clear? I hope you like this video. If you like the video, please share and subscribe to my channel. So in this year APSET 2020, we got all 6 questions are very simple and straightforward questions from complex analysis. In the next video, we will discuss some more questions. Thank you for watching.